Hello guys, welcome back to my YouTube channel Being Engineer. In this video lecture, we are going to calculate the center of gravity or the centroid of a given composite section. This is the given composite section for whom we are going to find the centroid or center of gravity by using these two formulas which are called as area moment method. In the previous video lecture, I delivered the lecture in Urdu, but some of the viewers insisted to record the video in English. So for those, this video is recorded in English. So let's get started. Before we start our lecture, remember these two formulas which we are going to use in the upcoming slides in the end of the lecture. First of all, one must know what is center of gravity. Center of gravity is the point through which the whole weight of the body acts, irrespective of the position of the body. It means it is the point over which the whole weight of the body is concentrated. And what is meant by irrespective of the position of the body? Or it can be anywhere inside or outside of the body or at the center of the any body which have any weight or mass, whereas centroid is the center of a plane figure. Two-dimensional figure is called as centroid. These figures have no weight or mass. As you can see here, these are few figures, geometrical figures which have no weight or mass, so their center will be called as centroid. The center of a circle is called as centroid. Similarly, the center of a square is called as centroid. So centroid is for two-dimensional figures, whereas center of gravity is for those bodies which have some weight or mass. So starting our today's topic, the given section, as you can see here, is a composite section which comprises of one triangle, one square and one semicircle. This is one triangle, one square and third one is semicircle. The next step is draw reference axis, which is the first step of solving this problem. Draw reference axis. As you can see here, horizontal axis is called as x-axis, whereas vertical axis is called as y-axis. The second step is dimensions of the sections, which must be given in the question. And the dimensions are 10 inches. The width of this rectangle or the diameter of this semicircle is 10 inches. The height of the circle, or you can say radius of the circle, is 5 inches, semicircle sorry, and the height of this rectangle or square is 10 inches, and the angle of the triangle given is 60 degree, and the rest of the angles will be 60 degree, as the sum of the interior angles in a triangle is 180 degree. So 60 plus 60 plus 60 will become 180 degree. So other two angles are also 60 degree. Now the position of the centroid will be determined by moments of area method. What is moments of area method? The formula I mentioned in the first slide are called as moments of area method formula. First of all, the first step is area of the regions. Now there are three shapes, as I mentioned before. These are 1, 2, 3 shapes. One is semicircle, second one is square, and third one is triangle. So we will have to find areas of these three regions separately. A1 is for semicircle. So the area of a circle is pi r square. Now this is a half circle and we will divide it by 2 to get the area of the semicircle. So it will become 3.14. It is the value of pi multiplied by r, 5 square. This is the radius of the semicircle or square divided by 2. We will get the area of semicircle, which comes out to be 39.3 square inches. Now the area 2. Area 2 is the area of this square. Area of square is equal to b multiplied by d, width multiplied by depth, which is 10 multiplied by 10. As you can see here, the width of the square is 10 and the height of the square is also 10. So 10 multiplied by 10 comes out to be 100 square inches. Now area 3. Area 3 is the triangle, and the area of a triangle is equal to base multiplied by height divided by 2. Now what is base? Base is the similar as that of square, that is 10 inches, whereas the height of the triangle is unknown. So to find the height of the triangle, we will use this formula: tan 60 degree is equal to perpendicular divided by base. Perpendicular divided by base. So that comes out to be base is 5 meters. We will split the triangle into two. As you can see here, we split the triangle into two. Now the full base was 10 and the half base will become 5 meters, 5 inches, sorry. So we will have to find h. So to find h, we will multiply 5 over this side. We will get 5 10 60 is equal to h. So by solving this, we will get h is equal to 8.66 inches. So by putting the value of b and h, we will find the a3, which comes out to be 43.3 inch square. Okay, now this is the formula of the triangle for area: b multiplied by h divided by 2, or you can say 1 over 2 base into height. So to find height, we split the triangle into a right angle triangle to find this height, and by using tan theta is equal to perpendicular divided by base, and we find the h, which comes out to be 8.66. To calculate the area 3, which means the area of a triangle, we put the values in the given formula and it comes out 43.3 square inches. Now the areas of all three regions have been calculated. Proceeding to next step, to locate the centroid of each region. As I mentioned that the center of a square is called a centroid, and the centroid of a triangle lies at the height of h divided by 3 from the base, and the centroid of a semicircle lies in the center. Proceeding to next step, now to find distance of centroids along y-axis. It's mean that we will find this height along y-axis, which means this height from up to this centroid, and the height up to this centroid, and the height up to this centroid, which means along y-axis. So to find, we will name it as y1. y1 is equal to r minus 4r divided by 3 pi, as the total height of the semicircle is 5 inches, or the radius of the circle is 5 inches, and the centroid of the semicircle lies at a distance 4r divided by 3 pi from the bottom, from the circular side. This is the value which you have to remember. Remember this value for semicircle, that its centroid lies at the distance of 4r divided by 3 pi from the circular side, from the circular side. So by putting the values of r and pi, we will get here r is equal to 5 inches, 4 multiplied by 5, it is the value of r, and 3 pi, same the formula for centroid of semicircle. Putting the values, we will get 2.12 inches. So the distance from the base along y-axis, which is y1, comes out to be 2.12 inches. So to y2 is equal to the distance from this x-axis to this centroid. Okay, now what we will do, 5, that is this 5 plus the total height is 10 inches, and the centroid lies at the center of the square, which is 10 divided by 2. So the total height comes out to be 10 inches. Now to find y3, that is the distance of this centroid from this x-axis, that is along y-axis. To find this height, we will sum up all three distances, that is 5 inches, 10 inches plus, and the centroid of a triangle lies at a height of h divided by 3, that is total height divided by 3. The centroid of triangle lies at a height h divided by 3 from the base of the triangle. So the height is 8.66, and divided by 3 is the location of the centroid of a triangle. By summing up all these three values, we will get 17.88 inches. So we have found all the values of y1, y2 and y3. Formula we mentioned in the first slide, that I told you to remember this formula, that was y dash is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. By putting the values of all these constants, that is a1 we have found in the previous slide, and y1 we have also find the this value. Now by putting these values one by one, we will get y dash. A1 is 39.3, and whereas y1 was 2.88, a2 is 100, that is the area of the square, multiply by 10, 43.3, which was the area of triangle, multiply by 17.88, which is the value of y3. This is the height of y3, and divided by the areas of all of three regions. Okay, so we will get the value of y dash, which comes out to be 10.34 inches. So this is the y dash, that the combined centroid distance along y-axis, which is 10.34 inches. Now to find x dash, as we are going to find the centroid to locate x and y values, we have found y dash. Now to find the x dash value, we can see here the given figure is symmetrical about y-axis. That is, the distances of centroid along y-axis is same because all the centroid lies on the same line. As you can see here, this figure, this composite figure is symmetrical about y-axis. It means the right side is identical to the left side. So all these distances are same along x-axis. The centroid's distance along x-axis are same. So the total length from here to here is 10 inches, and dividing it by 2, that is total height is total the width of this figure is 10 inches. To divide to find this distance, x1, or you can say x2 and x3, all x1 x2 and x3 are equal, so dividing it by 10 we will get 5 inches. So we have find y dash and x dash. Now what is meant by x dash and y dash? Let's go to the next slide. Y dash tell us that 10.34 along y axis. So this is the 10 point, this height is 5 inches plus 5, that is the center of this square, and a few above this 0.34 inches. If we go 0.3 inches above, so this point is the 10.34. so now x dash is 5 inches, so the half of this whole composite figure, the arrows where coincides is called centroid of the combined centroid of the whole figure, and it is called as center of gravity or centroid. So in this video we have found the centroid of this composite figure. In the previous video I have also discussed the finding the centroid of T section, inverted T section, L section, Z section, and a dam section. Also go through those videos will definitely help you out in locating the centroid of any composite figure. If you are new to my channel, you are requested to please subscribe it and press the bell icon so that you can get video updates.